Good morning, everyone. It is great to see that you're already all deep in discussion, and we definitely want you to get straight back into that. So my name is Obi Felten, and it's my absolute pleasure to welcome you here to the very first European Solve for X. Thank you very much for being here. As you will see, you will play a vital part in making this day a success. And Viola, who's my co-host over here, say hi, Viola, will tell you more about how it works later. Thank you for showing up to a conference that you've probably never heard about before. There's a couple of you here who have been to Solve for X, but most of you haven't. So in the run-up to the event, I got a lot of questions. You know, what is this about? What is Solve for X? Why is Google organizing this? Why are you doing it in Berlin? How does it relate to Google X? What's a moonshot, etc. So I thought I will just say for 5 minutes a few things to answer some of those questions. So the reason we're here today is to celebrate moonshot thinking. And I work at Google X, which is one of the teams at Google that works on what we call moonshots. The New York Times called us Google's lab of wildest dreams. We call ourselves a moonshot factory. And here are some of the projects that we work on. So self-driving cars, self-flying delivery vehicles, smart contact lenses for diabetics, flying wind turbines, and internet from balloons. And you might look at that collection and you say, like, do any of these things have anything in common? And in fact, all they have in common is that we try and solve very large fundamental problems in the world with the help of technology. And we exist because the founders of Google, Larry and Sergey, very much believe that you can solve some of the biggest problems in the world with the help of technology and make the world a better place. And that may sound, sort of naively optimistic, but they truly do believe in that. So when I first arrived at Google X about 3 years ago, everyone was talking about this moonshot thing, and I said, what do you mean? What is that? And I got a lot of interesting answers. So I decided to make a video. And this is the film that answers some of these questions.
The actual moonshot is wonderful, inspirational, poetic, beautiful, involved great technical challenges, genuine heroism. It brought the world together. But think about the Polynesian islander on the dugout canoe, deciding one day they were going to go that way. No one had ever been that way before. No one even knew if there was anything that way before. It was amazing, and it changed the world.
People can set their minds to magical, seemingly impossible ideas, and then through science and technology, bring them to reality. And that then sets other people on fire, that other things that look impossible might be accomplishable.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said, because it is there.
Everyone else in the world is working on that next 10%. If you can be the one that delivers that 10 times improvement, you have a chance to really change things.
If you want cars to run at 50 miles per gallon, fine, you can retool your car a little bit. But if I tell you it has to run on a gallon of gas for 500 miles, you have to start over.
You need a lot of courage in this work, and you need a lot of persistence. Even if you don't really 100% believe it's possible, like you might think, this might be possible, have the courage to try. That's how the greatest things have happened.
You don't spend your time being bothered that you can't teleport from here to Japan, because there's a part of you that thinks it's impossible. Moonshot thinking is choosing to be bothered by that.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Humanity's progress has been a series of amazing, audacious things, from the very small and personal up to the great, big, and grand. And we are a species of moonshots. And to me, that's like the really amazing, poetic, and inspirational thing.
When you find your passion, you're unstoppable. You can make amazing things happen. It's been true through all of history.
When Kennedy said that we would put a man on the moon, it's about the fact that he said, we don't know how to do this yet, and we're gonna do it anyway. And that sends chills up everybody's spine. Because if that happens, what couldn't we do?
Okay, great. So this is our definition of a moonshot. We want to start with a huge problem in the world, something that, if it was solved, would affect the lives of millions or even billions of people. We propose a radical solution, something that today sounds like science fiction, but then we work on a breakthrough technology that means that within the next 5 or 10 years, we think we can turn that science fiction from science fiction to real science. An example from the Google X world is self-driving cars, which was our founding project. So the problem is that 1.2 million people in the world still die every year in road accidents. So Sebastian Thrun, the founder who set up the project, his idea was, what if you take the driver out of the car? Because the self-driving car isn't distracted, it's never asleep, it's never drunk, should be a much better driver. And that was 20th century. In the 20th century, that was science fiction. But in the last 10, 15 years, advances in computer vision, in processing power, and cloud computing, in sensors, and in digital mapping are now making this a reality. So that's an example of a moonshot that we work on. But of course, we're not the only people working on moonshots. Many, many people across the world do. The lady you saw in the video, Megan Smith, is actually the founder for Solve4X. It was her idea. And she can't be with us today because she now has a new job. She's the Chief Technology Officer of the United States, which means she now has to get the US to work on moonshots, which these days apparently is much harder than in the 50s. But she's with us in spirit, and I wanted to thank her from all of us because you're the reason that we're here. You saw her sort of passion for the topic come through, I think, in the film. And so it's my pleasure to tell you the story of the origin of this conference that she otherwise would have told you. So they first discussed the conference when we set up X because we thought we would need to scout for ideas. So Megan said, why don't we have a conference? We'll invite lots of brilliant people, and they'll pitch their ideas, and then we do the best ones at X. In fact, we had quite the opposite problem. We have more ideas at X than we can possibly ever work on. So we kind of moved away from the scouting for ideas idea. But Megan said, why don't we do the conference anyway? Because there's lots of people out there, they have these ideas. Why don't we instead bring together a group of people who can help move these ideas forward? And that was the origins of Solve4X, which now isn't just the conference, but also an online community. And we've had over 50 community-led events across the world. So Solve4X is about celebrating who we call moonshot pioneers, people who have these ideas of solving large problems in the world with a breakthrough tech. And it's also about helping them move it forward. That's where you come in. Because they're not there yet. So they're not yet Nobel Prize winners. They're not yet Elon Musk. And that's where you come in, because you have to help them. So today we have 7 amazing European moonshot pioneers that are going to present their projects to you, which brings me to my last point of why are we here in Berlin today. The first 3 conferences, Solve4X conferences, we ran in California. I'm European. So is Viola, and so is Georgia, who many of you emailed with before, who can't be here today because it's her grandmother's 90th birthday, so she had to go to that. And we said, why are we doing this in California? We should be doing it in Europe. There's so much amazing work going on here. We should be celebrating not just the heritage, but also the future of Europe. Of course, we're the new kids on the block. We don't know the European scene as well as we do California at Solve4X. And the way we do projects at Google X, when we're ready to go out into the world, we get partners. So we did the same thing here. And I'm very grateful to our partners, which is the DFKI, the German Institute for Artificial Intelligence, and also the Hasso-Plattner Institute. They helped us find moonshot proposals. They helped us find the audience, so some of you are here because of them. And it's now my pleasure to welcome to the stage Professor Dr. Wolfgang Walster, who's the head of the DFKI. And he's going to tell you a little bit more about why Berlin, in this building in particular, is such a great place to discuss moonshots.
Thank you very much, Obi. My name is Wolfgang Walster, and I just wanted to point out that here we are at a place which is really historical. We are really at the right place for moonshot ideas. Why? Because only 200 meters from here, Gottfried Wilhelm Leibniz, actually 300 years ago, founded the so-called Prussian Academy of Sciences. And in the next 5 minutes, I want to tell you what is the relation to Google Solve X idea. This society also had the Humboldt brothers as members, and today we are in the Humboldt building. The name comes from these two guys, both professors, and the interesting thing, Alexander von Humboldt, he was in the natural science, in biology, anthropology. He traveled through all the world and described wonders of the world. And Wilhelm, his brother, was in the humanities. And from the beginning, this society discussed problems between science, rocket science, and the humanities. That was unique. And today, of course, Prussia doesn't exist anymore. Now it's called the Berlin-Brandenburg Academy of Science. It's also only 100 meters from here, the building. Actually, I'm a member. We have 78 Nobel Prize laureates, so it's a very good society. It includes Einstein, Max Planck, Heisenberg, Schrödinger. There's a long tradition in physics and chemistry, but also people like Grimm, the Grimm brothers in lexicography and the humanities. It was also quite international as we are here. It's not just the German Academy. There were people from France. One of the first members was, for instance, Voltaire from Paris. Let me talk a little bit about Leibniz. Leibniz was one of the last, I would say, really polymath guys. He was working, like all of you, in a very interdisciplinary fashion on grand challenges, and actually he said, I want to solve some moonshot problems of my century. Most of the tasks he got from the king. Yeah, the king asked him to give advice, and what he did, for instance, he invented the first calculator, mechanical calculator, with all 4 arithmetic operations. For us in artificial intelligence, and actually Sebastian Thrun in the Google car is using this automated reasoning. You have to do some reasoning if you want to act autonomously, and this is based on logic, especially predicate logic. He was the one who invented the notation for predicate logic. From school, you know the integral. This is his scribbling when he invented the integral, symbol, matrix multiplication, Boolean algebra, but also very practical things, like the king asked him to build mining machines, hydraulic presses, lamps, even submarines, clocks, what have you. And most important, I think we wouldn't sit here with Google if he wouldn't have pushed the binary number system for computing. I think this was around 1700. For our discussions later today, I think his saying, his famous saying, let us calculate without further ado to see who is right, was a very extreme position in science. Namely, he said we can formalize our arguments in such a way that actually, like in mathematics, we can prove who is right. We will see whether this works later when we discuss the moonshots. Now, the relation to Solve X. In 1700 already, the Royal Society of London, of Paris and Germany, they all had the idea you should actually ask people, the academicians, for solving great challenges. And so every year they formulated a question, and there was also a big reward. In Germany you got 20 ducats, golden medals from the king, when you solve one of the questions. Let us look at some of the questions. What is the inner structure of the ear and the process of hearing? Partially solved. Not yet completely, because we still don't understand completely how hearing works on the neurophysiological level. What is the origin of language? Question still not solved today. How can we calculate the orbit of comets? This is completely solved. We can do this as simple computation. Should the state deceive the people for their own good? Very interesting question. This is a political or ethical question, not solved, I would say. The last question, and you see some of these grand challenges fade away. It's nonsense today, it's obsolete. But at that time, it was correct, because even people here, the King of Germany, spoke French, not German. And all these people, you know, it was French. So the question was answered, but again, not relevant anymore. And as I said, the cash prize. And what was most interesting, and this is missing here, that actually the king came to solve X, so to speak. Actually, he invited people to Potsdam. Here you see Leibniz and Voltaire sitting, discussing the answers to the solve X question. So it's a very long, interesting tradition. Finally, who is giving gold medals today? I'm also a member of the Royal Academy in Stockholm, where we give the Nobel Prize. Every October in a secret session, we think about, who should get the Nobel Prize in physics and chemistry. I'm involved for 10 years, and I can tell you, also it's confidential, that all of these prizes today are based on computing. There is no prize in Stockholm which you can get without informatics. I think the power of innovation comes not from mathematics today, but on the higher level, looking at processes, computational, on algorithms, methods, where we really can solve problems in real time. And I think Obi gave very good examples of this. And I think if we work hard today, I'm able at least to propose people here for the Nobel Prize. Maybe we find somebody, and then you get this nice Nobel Prize medal of gold. And I think what is printed on this medal is very important. I think it fits to what Obi just told us. They who bettered life on Earth by their newly found mastery. I think it's a good motto for today's thing. And as I said, I think I'm a strong believer that most of the innovations we will discuss today in the Moonshots are based on informatics. Thank you very much for your attention.
Hello, everyone. I am Viola. I am the program manager for Solve4X. I'm also based with Obi in California, but I'm European myself, so I feel like I'm back home here. I'm really happy to be here. This is our first Solve4X event, our flagship event in Europe. So this is a very exciting day for us as well. So I want to tell you a little bit more about what we're going to be doing today. We're going to be having 7 amazing speakers. The magic really happens in Solve4X when we have an amazing group of people like you, a mix of polymaths. So you will find that in your groups there are some people who will be experts on about that topic that has been presented on stage. Some people will not know so much, but that is the amazing part, right? This is where the magic happens. We get people talking about the challenges that you're going to be posed by the pioneers themselves, and we'll be telling you a little bit more about how the day works now. So this is the agenda. We'll be having 3 Moonshot sessions. In a Moonshot session, you'll be presented with 2 to 3 different presentations. So the scientists will be coming on stage, and they will be giving you a 10-minute proposal. But it's not a normal conference. You're not just going to sit and listen to what they're saying. You are an integral part of this conference, because what's going to happen then is that after a group of 2 or 3 presentations, you will be assigned one of the proposals, and each pioneer is going to give you a challenge. So they will tell you, so one thing that I want to solve right now is this problem. Can you help me do it? So while you're listening to these presentations, what we want you to do is to really think, what is it that, are there any bells that are ringing? Do you know anyone else who is talking, who is already working on something similar? Do you know of any technology that is already, that might be already solving the problem that he's facing or that she's facing? And the magic really happens when you have, for example, a physicist who is on stage, and if there's a biologist in the audience who says, wait a minute, we've already solved that in my lab. I know how to fix your problem. So the reason why I love my job is exactly because of this process, is because we bring people together in the same room. And when you find there are lone scientists out there who are working right now, and imagine the Elon Musk of 10 years ago. And the best thing that you can do for a guy like this is to introduce him to like-minded individuals, people who are facing the same challenges, and people who might already know how to solve their problems. So that's the reason why we're here today. The way that the brainstorms are going to run, we borrowed this concept from improv. So it's very easy to hear new ideas and say, nah, that won't work. And that's not what we want you to do. So keep a very positive mindset, an open mind. So the first thing that we want you to do is to spend 2/3 of the time thinking, yes, and. OK, what are the possible connections I can make? Who do I know that might help this guy or woman? Who do I know that, or what have I heard of? And keep on adding on each other's ideas. If someone mentions something, then say, yeah, and what about this thing? And feel free to, if anyone goes, nah, that's not going to work, feel free to tell them, OK, no, you're not doing the right thing. Yes, and remind them. We're going to be spending a very small amount of time, 1/3 of the time, going yes, but. And in yes, but, what you're going to be pointing out are potential pitfalls. So what maybe has not been considered already? Is there a reason why this might fail that maybe the presenter doesn't know about? And it's more of, let's bring this to their attention. Let's say, for example, there's been some work in that aspect, and the reason why it didn't work was this and this, but maybe this hasn't been tried, this part hasn't been tried yet. So again, we want you to spend 2/3 of the time yes and, 1/3 of the time yes but. OK? Perfect. And one common question that we get very often is, can I tweet? Can I post? Can I share on social media? And the answer is yes, but. And the reason why the answer is yes, but is because you are free to post about the speeches that you hear on stage. So feel free to take pictures, or feel free to post about whoever is here on stage talking about the proposals. But please do not discuss anything that is in the brainstorms or who said it. And the reason why this is important is because we want everyone here to feel free to say anything that comes to mind. No stupid ideas here. Don't feel pressured. Just contribute. We have you here because we know that you are brilliant minds. So again, tweets about the event are fine. Posts about the event are fine. Use our hashtag. It is SFXBerlin. So SFXBerlin, and our Twitter handle is @solve4x. And make sure you don't post anything about what people say or who said it. That works? Perfect. OK. So wonderful. The one last thing is you will see 10 people in the room who are drawing on these easels. We are lucky today to have 10 of the most talented artists of Berlin. So thanks for being here. These talented artists will be sketching the ideas that are coming out from your brainstorms. So we will have a physical output at the very end of the ideas that you are coming up with. So they will be drawing a little bit more about the proposals that the people will be here on stage talking about, and then they will also be writing down the ideas that you come up with. Perfect. So I'd like to first introduce our very first speaker. He is Rodrigo Garcia Gonzalez. Today he will be presenting Uhu. So it is the alternative to the plastic bottle. And Rodrigo here is a true global citizen. So he has studied in Spain, India, Chile, Sweden, and the UK. He has a master's in art and engineering. He is currently a lecturer of industrial design at Kingston University and a visiting tutor at the Royal College of Art and Imperial College of London. And he also runs a startup which is called Skipping Rock Lab. And he is going to be telling us about how his team is using biomimicry to create edible water bottles. So please, a round of applause for Rodrigo.